Hi guys, thank you for joining today. Uh, this is Marcos Arancibia here. You joined the Oracle Machine Learning office hours usage highlight. Today we're going to be taking a look at Oracle Stream Analytics with real-time Oracle Machine Learning services scoring. So joining us today is Thomas Vangel. He's going to be taking over the presentation and showing you guys a great set of slides and talking about his demo. And joining with me today is also Sherry LaMonica. So if you guys have any questions, remember to use the Q&A panel. And that's it. With that, I'll take it away, Thomas. Thank you very much for doing this for us.
Yeah, thank you, Marcus, for the great introduction and having me here. Hello, everyone. My name is Thomas Wengel. I'm the product manager for Oracle Stream Analytics, also known as GoldenGate Stream Analytics. I'm based out of the Bangalore office in India, and I'll be doing this presentation today. And if you have any questions or something is not clear, please feel free to ask questions through Q&A. All right, so let's get started. So in today's session, what I'm going to show is the first we'll go through the Stream Analytics marketplace predictions, customer business use cases, technical use cases, and user personas. Next, we'll go through the product features and differentiating features when compared to other competitors. And as a third part, we'll go through the OML integration. That's a new feature that we introduced, which includes architecture and usability areas. And as the fourth part, I'll show you a quick demo of how the integration happens between Stream Analytics and OML. Lastly, I'll also take you through a couple of recent customer case studies in the stream data processing use cases. Okay, so real-time data is very important in today's digital world. Real-time data is produced from multiple places and multiple systems as customers build and deploy applications in different platforms. This could be running on different clouds, private or public. And today's data analytics industry is going through a vast change with new technology advancements. And in the recent times, there is a lot of IT spending that will be happening in the next few years. So in this Gartner study, top 100 data analytics prediction through 2024, $60 billion will be spent on data integration because of the demand on intercloud and hybrid deployments of data stores. Majority of these new integration would be using AI as a top criteria for simplifying integration, automated insights, and no-code application development. It seems that more than 50% of the new integration technologies will be using AI. More than 65% of new code by 2024 will be low-code application development, and 65% of the business leaders say that automated insights from AI operations would be much higher than what it was compared to 3% way back in 2020. Okay, so now let's get into the business use cases of Stream Analytics. So there are two major sets of business use cases in the streaming analytics world. Firstly, it is driven by an IT initiative for modernization of their data systems. It is marked in the dotted line box on the left top. Here, IT teams would like to modernize their newer systems like data warehouse or cloud data lake ingest, or create a new REST-based or publish subscribe based enterprise data services. There are also use cases of transforming the data in real time, also known as streaming ETL or real-time data pipelines. Another initiative can be categorized as data operations, or the new term is the AI ops, and also called as operational insights for real-time dashboarding. The other set of business cases are very specific to all the industry verticals. So let's say that most of them are financial services or transportation or telecom, retail, manufacturing, utilities, and healthcare. So if you look at specific use cases in one of these industries, it could be a fraud detection or risk management in financial services, or it can be similar fraud detection and risk management in healthcare or even telecom too. Similarly, monitoring of delivery vehicles or optimizing logistical routes in the logistics business, or you're looking for outages and real-time telemetry in utilities like electricity, gas supply, etc. Now let's look into the technical use case. So when you look at technical use case, you're looking to source data from various different sources. It could be files, it could be REST endpoints, it could be messaging systems like JMS or Kafka. It could be other tools like GoldenGate, or you could look for data from the database directly. So the data sources that are there from the left are basically processed using Stream Analytics under the various use cases, technical use cases such as event correlation or anomaly detection or window compaction, or spatial data processing, which is basically the geographical boundary analysis, or the old school of complex business rules where you have a lot of business rules that are defined, or the new age operations called as the AI ops, which does a lot of forecasting, event scoring, or predictive analytics, and dashboarding if you want to create some real-time dashboards. Now let's look at who are the various different users here. So in the past, most of the users for the Stream Analytics have been data analysts. But however, we are seeing two new sets of users coming into the picture. They are the database administrators and also the data engineers. So data analyst in the past was basically looking at most of the data contents and preparing some machine learning models or some statistical models in the past, creating dashboards and visualization, or creating rules and business rules, or any of those kind of use cases. But today what we are seeing is the database administrator who manages the data and the security and the users. All of that are now responsible for the data in an enterprise, and they are also the ones now using tools like OML, provisioning OML services on the database and administrative services. And on the other side, what we see is the data engineers, who are the new age ETL developers, or you can also call them as the big data developers, Hadoop developers, who creates a lot of systems for complex windowing correlations, or they're trying to run the big data systems and messaging environments, or they're trying to do some creating pipelines in the ETL world. So let's see what are the process, high-level process of how you create a real-time data pipeline. So when you're creating a new data pipeline, there are three main stages, and these three main stages can be considered into 5 sub-stages. The first stage is data ingestion, where you bring in the data from various different sources like sensor data, or social media data, or clickstream data, or even database change data, capture data as well. So all these data, when they come into the system, they are not good for processing into their algorithms or models. So you need to actually do some pre-processing. Though the pre-processing can be considered as a transformation that you do on an ETL tool, which could be filter or aggregate transformation, or doing some correlation lookup, and many such things. Once that data is ready for processing, they can be sent through the next stage, which is the the analysis or prediction stage, where you run the data patterns or window patterns or machine learning models here. Once the data is processed, the next stage is basically going to review or analyze that in the conditions of the business rules, or we call it as a decision stage, where your business rules, policies, and logics are applied. And based on that, the data is taken to the next stage, which is the final stage called as action. So the data can be published into an external pipeline or external tool, or you can invoke an application or execute it in a tool. You can visualize, do some real-time visualization, or you would like to persist the data in a data warehouse or data lake, you could do that. So now let's move on to the product features and differentiators. So there are some interesting features that there for GoldenGate Stream Analytics. So the first one, the tool can be used by a business analyst or data analyst, which has a simple UI to create data pipeline in few minutes. It actually hides all the complexities of distributed computing infrastructure like Hadoop or Spark, Yarn, Kafka. Everything is hidden underneath in the application. So it is much simpler for an end user to use it. It supports custom programming like Java. So if you have a custom program that you could import into the tool, or you can also run something called as CQL, which is continuous query language that is built into the tool, which is more like a SQL. It has a good set of connectors to source data from relational databases or NoSQL databases and deliver to big data, or even to cloud ecosystems like AWS or OCI or Azure systems. It has capability for deploying it anywhere. That means you can design it on-prem and run it on the cloud, or you can design it on the cloud and run it on-prem, or you can design some part in cloud or any of those kind of hybrid manner. So you could run part of it in cloud, part of it in on-prem as well. So it has a capability, to create, machine learning model. So you can create a machine learning model as a custom application, and whether it is a static or dynamic model like an OML. So you can import into the tool, or you can make the tool to run it externally in a 24/7 mode. You have simple, tools to create charts and dynamic dashboards from a pipeline. And also we have some starter kit, which is ready to use patterns, and also half a dozen demo pipelines, which are available for, geospatial processing and ML stages. So what are the core differentiators of this product? There are 6 core differentiators of Stream Analytics product. First one is that it is a simple browser-based interactive UI for designing of pipelines by data analysts and business analysts. Second one is that it has direct integration with Oracle GoldenGate to provide CDC data from relational databases and NoSQL databases. Third is that it has a rich set of streaming patterns, which are protected by Oracle patents, over 70 patents to be almost precise. Fourth is that the integration with various maps like Open Maps, Google Maps, custom tiles for geospatial analytics. Fifth is that it is built on the latest open source technologies, which are for the distributed computing architecture. It is using Apache Ignite as an in-memory data caching system. And for lookups, Apache Kafka as the data streaming platform. And it is built on the distributed computing architecture with Spark streaming execution engine. 6, and the last but not the least, it has a capability to use machine learning models in the streaming pipeline to do scoring and doing predictive analytics. So here is a quick snapshot of all the features that we just talked about. On the leftmost, you can see the interactive low-code designer, and left bottom, you see the patterns and accelerators that are ready to use. And on the right bottom, that you see the predictive analytics and machine learning model. And and in the center bottom that you see is the geospatial analytics and geofencing capability, how you can draw it on the map. So it's a low-code tool which can be used by data analysts directly to build and embed real-time dashboards that are event-driven. And these are not SQL dashboards, right? So that needs to be refreshed, or dashboards that run continuously and have all the events pushed to them in real time. So there is a lot of things that are going on in this chart now, but it's just included to give you a flavor of what is there in the graphical language of this tool. So a quick snapshot on what are the sources and targets that are supported by Stream Analytics. You can bring in any GoldenGate extract or any GoldenGate sources that supports the various different database sources. It includes relational as well as non-relational. Or you can source data from Kafka systems, the data that is brought in from IoT systems, or you can also bring in data from legacy applications through JMS. And also you have lookups and other integration with Kafka, Oracle database, MySQL database, Apache Ignite, REST, ADW and ATP, OCI streaming service, Azure Event Hub, AWS managed Kafka. All of them can be considered as sources. And on the sources as well as targets. And on the target side, we support a lot of big data systems from the on-prem Hadoop or SDFS, Apache HBase, Hive, MongoDB, Elasticsearch. And on the cloud side, we support OCI Object Store, OCI Big Data, Azure Data Lake, and AWS S3. And quickly, summary that GoldenGate Stream Analytics is today available on OCI Marketplace. It is available for less than $1 per hour per row CPU today. So it is easy to provision. You can provision it in under less than 5 minutes. And if you'd like to see the product in use, or if you'd like to try the product, we have a free trial that is available on the Live Labs. And for getting the Live Labs, you can actually search on the Google for GoldenGate Stream Analytics Live Labs, and this will be the first link that you'll get in. Okay, so now let's get specific into the Oracle machine learning integration. So there's a new feature that comes out as a part of the 19.1006 version. And just wanted to give a quick recap on the OML services architecture. So Oracle Machine Learning Service is not in the autonomous database, provides access into database machine learning features. So OML service basically extends your OML functionality to support the OML model deployment and model lifecycle management in both in-database OML models through REST APIs. So the REST API of the Oracle Machine Learning Service provides REST API endpoints hosted on Oracle Autonomous DB. So these endpoints enable you to store machine learning models along with its metadata, creating scoring endpoints for the model. And OML services users are basically created on the ATP and ADWs or ADWC. Now let's look at the Oracle Stream Analytics to Oracle Machine Learning Dynamic Integration Architecture. So here you can see that the first stages, you load the data into the historical data. You load the first training set of data into the autonomous transaction processing or ADW system. Now you prepare the data set using feature engineering methods that can be used for building machine learning models. Once you create the machine learning models using OML, now you deploy that model into OML services. Once you deploy the model into OML services, you can create a pipeline in the Oracle Stream Analytics with your various data sources and pre-processing stages. And then you create a stage called as machine learning OML scoring stage. And that stage basically have an integration into the OML services and using the REST endpoints. So when the streaming data flows through the OSA pipeline, the OSA would access this machine learning model through the service-oriented interface with the streaming data that needs to be scored, and it responds back. The service call would return an ML scoring results, and it would be used for the next stages of the data pipeline on what decisions that needs to be taken, or how the data should be sent to the next phase. So this is a block diagram. So now let's get into the actually the cloud architecture and topology. So you have various sources that are coming in. And before that, first the data scientist would analyze the data, then prepare the data on the autonomous database, and they would deploy it on the OML services. So you can see that the data scientist would first prepare the data model on the autonomous database and then provision it on the OML services. It could be on a separate subnet, or it could be on a separate region as well. And Oracle Stream Analytics, it is running on a separate subnet or separate instance on the OCI. Here, data engineers would develop a pipeline, and this pipeline would have various different sources that are coming in, and this would interact with the real time. Interact with the machine learning model in real time, and this result is basically processed and next stages, and then it would be sent into various different targets like real-time messaging systems or big data lakes or business process applications or alerted notification like an OCI notification service or data science and data marts as well. So now let's quickly look at the OML OSA UI patterns on the OML. So there are two options. The first one is you can create a new pattern using the OML service that is a ready to use pattern. And the option two is once you're in the pipeline editor, you can create a machine learning stage in that option. And OSA UI, it is pretty simple. There's all what you need, all these basic configuration parameters like an OML service server URL, tenant name, service name, username, password, model, and the input fields that you would like to provision. And if you're looking at OSA UI for ML integration, then you have an option to score it in as an individual event or as a batch event to process. So now let's get, so this is how the final look like, how the UI looks like, how the scoring results would show up in the pipeline. So now let's look into the demo. So here I'm logging into the Oracle GoldenGate Stream Analytics UI. And here, what I'm going to use is I'm going to use an OML model that is prepared by Marcos, and I'm going to use the GLM model that is available here. And in Oracle Stream Analytics, once I log into that, so before that, I just want to show that the model is deployed into the OML services, and I've made a query I've imported the token and made a query to see what are the services that are deployed or what are the models that are deployed on the OML services. So I can see that my GLM class model is deployed in the OML services, and I'm going to use this directly in the tool. So here is a homepage of Oracle Stream Analytics, and it's talking about 6 ready-to-use tools or demos or training pipelines are available here. Some of them have machine learning models that are inbuilt. So this one has a machine learning model inbuilt. So I was talking about how the system settings are done. The system settings basically talk about where you provision your Kafka. It could be on-prem or it could be on the cloud. You could run your Spark on the cloud or on-prem. Similarly, you can run your runtime can be a Spark standalone or a YARN model as well. And you can specify these pipelines. You can have any number of executor accounts, either as a system setting or at a runtime setting. So you can, based on the volume of data, you can scale your systems with your Spark nodes and big data or Hadoop nodes for the higher number of execution. And a lot of other user management and many of the other configurations are available. So now looking at the catalog. So here is a catalog. So the catalog catalog is where you actually create a new pipeline or first you create a new connection. It could be file connection, or it could be a Kafka connection, or any of those connection. And then you can create a stream connection from any of the other data sources. And then you could create a pipeline and any of the other models that you're creating here, right, in the systems as targets or other models. So here in the catalog, we have all the artifacts that are listed here, or what all the resources, and all the resources can be tagged in specific tag name, and they are filtered with the different types. So you can look at the specific models here, the streams or pipelines. All of them can be looked at. So I'm going to see all of them, and I'm going to filter with my name as tag. So I've deployed a pipeline. So before that, I'll just show you how I create a stream on the source. So there's a file stream, and the stream has data that is coming from the Iris dataset. That's what the model is built on. The GLM model is built on, and I'm sending the even by 4, and the data sources are sepal length, sepal width, petal length, and petal width, and also species, which is coming as text data. So this data is now pumped into my pipeline. So let me open my pipeline, and it'll open up the pipeline editor. So you can see that the data is coming from the input source in real time, and the sepal width, everything is coming in real time. Now this is passed into the next stage, or I can the next stage, which is the machine learning stage. And here there's a published pipeline, so I'll not be able to edit any of these. So I give the OML server URL, tenant name, and OML service username, password, and the data is input field is sepal length and sepal width, and the scoring would happen based on the inputs that is configured. And I can also create visualizations here. So I can create a pie chart, or I can create a bubble chart. I can create a stack bar chart. All of these various different charts can be created, or there are many more charts that are available to be used. And once you create these visualization, you can actually display it as a dashboard. Also, you can create as a dashboard and publish it to an end user to see real time data getting populated. So all of these data would be getting populated in real time. So you can see based on the data flow here, the data would be updated, or the dashboard would be updated in real time. So, so that's the quick areas, and I just wanted to show you that the various different patterns that are available. A lot of ready-to-use patterns that are available here today, and this is the new feature that we have for machine learning. And this is a machine learning new feature that we have built in as a part of the 19.1006 version. So quickly going in for the last as a customer reference. So been fortunate to have a very good customer reference that came up in the last week, or sorry, this week, and been happy to share that SailGP has actually adopted Oracle Streaming Analytics as the tool for the real-time data processing. So SailGP is a sailing Premier League and have expanded their successful data analytics platform using Oracle technologies. So they're going to use this from the April 21st or 2021 season to provide real-time race metrics. So they use sophisticated correlation patterns, data enrichment, and machine learning. Oracle Stream Analytics makes the autonomous decision based on the 30,000 data points for an F50 catamaran, which sends data on every second, for every second. So in the past, they were actually running 10 streams, but now they have, with the Oracle Stream Analytics, they've made it as a single stream to make it work. And a quick architecture of their deployment. So they have data that is coming from race helicopter telemetry, support boat telemetry, and race boat telemetry. They all go through the racing venue, Edge IT, using, and the tools basically process that first stage data and send it into OCI Cloud, which is going through an OCI streaming and GoldenGate Stream Analytics. And they're also going to look for adopting autonomous DB and OML with the notebooks before they publish the application tools into the other targets. Similarly, we have a new use scenario or a new use case where edge computing can be done with Oracle Stream Analytics using the Oracle Rowing Edge appliance. And here also the architecture looks pretty simple, pretty similar. And here the difference is that they're also using something called as GPU-based MSET2 machine learning algorithms in one of the stages for quick integration. So here you have the edge device, and then once the data is processed, they'll send it into the OCI cloud as semi-connected or disconnected integration. Okay, so looking at the time, we are at the end of the hour. So we have I have some follow-up data that you can look up. So we have some blogs on data fabric strategy. Oracle has been ranked as #1 by Forrester on that. We have an Oracle GoldenGate YouTube channel for on the data mesh and the strategy and the architecture patterns. We also have the free live labs and the cloud marketplace integration. Okay, so that brings us to the end of the session, and I can spend a few minutes if you have any questions.
Thank you very much. Yeah, that was an excellent session. Thanks a lot, Thomas. And there has actually been a lot of great questions. So if we go to the Q&A, we can start by a question that was asked by 2 people, I think. So in terms of what's the difference between the stream analytics and the OCI streaming?
Okay, yeah, so both are different. OCI streaming is just a messaging infrastructure. You can say it as something similar to Kafka on the cloud, or the Event Hub on the Azure or Amazon Kinesis. And the Stream Analytics is more like the Kinesis Analytics, or equivalent to Microsoft Stream Analytics or Azure Stream Analytics. So they are totally different. So one is just shipping the data from one place to the other. And Stream Analytics is actually doing the data processing, including machine learning analytics. And the next question, most people are interested in running OSA on OCI through the paid marketplace image. Could you please elaborate on how this deployment option applies to content being presented? Can one set up a distributed OSA cluster using marketplace image So today we don't have cluster option, but we have options of special images. So Oracle Stream Analytics runs in two stages. One is a deployment, one is a design mode and a runtime mode. So the runtime mode is where you would run clusters of infrastructure. So you can have your own Hadoop infrastructure, or an Oracle BDS kind of equivalent service where you can run it as a cluster. And OCI itself is a high available system, so it is used for mostly design purpose. So even if you want to provision another instance, you can have that as a backup option separately. And then
yeah, then so the machine learning models, right, deployed in Onyx format. So OML services, the model you were using is an in-database model, right? It's a serialized model version. But with the same kind of call, you could easily call our Onyx format because it's just a different REST endpoint. So that will be the same process. The only difference, and actually is a question to you, Thomas, because when the model is a machine learning in database algorithm, we know that the time, right, that it takes for scoring is usually between maybe 80 milliseconds, 100 milliseconds, depending on the data center you're working with. If the model is of a type Onyx, it might take a little more time. So I've seen everywhere from 400 milliseconds, and depending of the complexity, of course, of the Onyx model, it potentially could even go up to a second. So I think that's still not going to be a problem for you, right? And the tool accounts for that delay or difference anyway, right?
Yeah, so that's something that we can actually work on. So we are looking to include the Onyx model as a as a pipeline, as a stage to be imported into the pipeline itself. That means you can bring the Onyx model directly into OSA.
Oh, okay, I see.
If you want to do that, that's not there today, but today we support only PMML, but we are looking at Onyx as well. So if there is a performance improvement that you would need, you can deploy directly those Onyx model, in the near future when the feature is available.
Oh, okay. That'll be, I think, a good idea. All right.
How does model training happen in such case? My understanding, yes, model training will be done in ADW. So OSA will not be doing any model training. Model training always happens outside of OSA. So it can happen on OML, or if you are a customer who is using Python and outside notebook, you could use that as well. So all of that is possible. So is OSA on drawing edge available to commercial customers? Yes, I think you can work with those teams to make it available. It's available as a special image where you can get OSA along with it. So can Stream Analytics consume graph data types? No, we don't support graph data types at this point of time. Does OSA require ADB as a dependency? So if you're using OML integration, then you need ADB as a dependency, right? So if you're using OML services is run as a part of ADB. So you need ADB access, or the username and password and all that details. And you also need to publish that model in the OML services. So, and the user provisioning happens on ADB, right? So that's a dependency if you are using OML integration. Can I always say output be visualized to Looker or Tableau? So we don't, I mean, you can direct it as a stream to as a REST endpoint or Kafka, and then you can consume it from Tableau. We don't support directly Tableau as a target. So you need to, transform the data in the Tableau format for consuming it and have the integration with it. All right, so thank you for having me here. I hope the session was interesting and useful. And yeah, thanks, Marcus, for hosting me here as well.
Sure. Thank you very much, everyone. And remember, you can always also ask your questions in Ask Tom. I really appreciate you guys being here, and talk to you next week. Thank you very much, Thomas, again. Excellent. And thank you, Sherry, for supporting.